In this lesson, we're going to learn about the different types of quadratic forms that we can have when we're talking about our equations and how we can go back and forth between those two forms. So there's two different main forms of quadratic equations that we're going to be working with. The first is vertex form, which we've kind of already talked about in previous lessons. It's f of x equals plus or minus a times x minus h squared plus k. And so this is really good for key attributes because we can really easily find our vertex from the points h and k. Standard form, we're going to be using f of x is equal to ax squared plus bx plus c. And this one's going to be really good for solving because it's already in the form that we have used before for factoring, which is going to be really important when we start looking for solutions of quadratic functions. And so we need to be comfortable with both of these forms of quadratics, and we want to be able to go back and forth between the two. And when we go back and forth, when we're converting, we are keeping the same equation, or the same function, the same graph, but the equations are just going to look a little bit different. So first, let's see how we're going to go from standard form to vertex form. And each of these are going to have 3 steps. So for my first step, I want to find the axis of symmetry with the formula. We're going to use x is going to be equal to negative b over 2a. Okay, so this is the formula we're going to be able to use to find the axis of symmetry. So what I mean by that is we have ax squared plus bx plus c. So to find the axis of symmetry, we're always going to write it as x equals. I'm going to take my b value, which in this case is 8, but I also need that b value to be negative. So I'm going to say negative 8 over 2 times my a value here is also 2, so I'm going to say 2 times 2. 2 times 2 will give me 4, and now negative 8 divided by 4 will get me a negative 2. Now that I have my axis of symmetry, I can use that x value to find the y value, which will be our vertex point. So I'm going to plug this x value we just found back into the equation for x, and that'll tell me my y value. So I'm going to say y equals 2 times negative 2 squared plus 8 times negative 2 plus 6. And now when I solve this, I'm going to get my y value of the vertex. And so we can say 2 times negative 2 squared would give me 4, plus 8 times negative 2 plus 6. So now 2 times 4 is 8, and then plus, or sorry, now we're going to have minus. 8 times negative 2 is going to give me a negative 16 plus 6. And then I can group these to say negative 16 plus 6 is going to give me 8 minus 10, which is just going to give me negative 2. So my vertex point is at the point negative 2, negative 2. And so now for my last step now, I know the vertex, so it makes it super easy for us to plug it into vertex form, because all we need to do is plug in our a, h, and k values. So let's remember that our vertex form was y equals a times x minus h squared plus k. And I know my vertex, the x value of my vertex is h, and the y value of my vertex is k, and this a value is going to be the same that it is up here. So when I plug these in, I'm going to get f of x is equal to my a value, which is 2, times x minus my h value, which we said was negative 2 squared, and then plus my k, which is negative 2. And if I clean this up, I'm going to get f of x is equal to 2 times x plus 2 squared minus 2. Now let's do the opposite. Let's go from this vertex form back to the standard form and see if we get the same thing. So here's the same vertex form formula that we just came up with. When we do this, my first step is we've got this binomial here that's being squared. We want to multiply that out. So I'm going to do the box method here. And remember, when we're squaring something, it's just like multiplying it by itself. So I'm going to say x plus 2 on top and x plus 2 down the side, because this is the same as x plus 2 times x plus 2. So now x times x will give me x squared. 2 times x will give me a 2x, another 2x here, and then 2 times 2 will give me plus 4. And now I can combine my like terms, which are these two 2x's right here. And so now I'm going to plug this value back into these parentheses. So I'm going to say f of x is equal to 2 times x squared plus 4x plus 4, and all of that is minus 2. Okay, and now that I've done that, I'm going to distribute. We won't always have anything out here to distribute. Maybe a is just 1, and so we wouldn't have to do anything then. But I want to distribute this 2 to all 3 of these terms. So now f of x is going to be equal to 2 times x squared is 2x squared. 2 times 4x will give me plus 8x. And 2 times positive 4 will give me plus 8. And then I'm going to bring down this minus 2. My third step now is pretty simple. All I have to do once I'm to this point is just combine my like terms, which is just this 8 minus 2. So I get f of x is equal to 2x squared plus 8x, and 8 minus 2 will give me plus 6. So I did end up back where we started with the original standard form. And so now I want to prove that these two are actually equivalent. So I'm going to hop over to Desmos and do that now. Okay, so we found the two standard form and vertex forms. My first problem, my standard form, was 2x squared plus 8x plus 6. And so I type that in and I get this blue graph here. And then my vertex form that we found was 2 times x plus 2, and that's squared, and then minus 2, and I get this green graph. And I see, if I uncheck it, that these two graphs are exactly on top of each other, which means that they are equivalent. So to summarize, we have two different forms of quadratic equations that we could be working with. We have standard form and we have vertex form. Sometimes one is better than the other for certain things that we may do with our quadratics. But it's important for us to be able to go back and forth and understand that it's the same exact function, it's the same exact graph, just represented in two different ways. We've got 3 steps to do those, which we've outlined in the notes. So I hope you had as much fun as I did with this lesson, and I'll see you in the next video.